Well, there's no need to kind of get angry about it here. I mean, it's just lesson 10, people. All right, so lesson 10 here, angle problems and solving equations. So we're going to kind of work on vocabulary here, and this is going to kind of serve us as what we're going to be relying on over and over again. So first thing we're talking about here is adjacent angles. And these are, well, if you think about the word adjacent actually means next to, and that's what we got going on here, angles that are right next to each other. Now, it's a little bit more formal than that, but that's really what it is going on. Adjacent angles actually always share, all right, a common ray. Okay, so if we look right here, they're sharing that particular ray. All right, one off the one angle and then off the other particular angle. So that's how we know that they are adjacent angles. What we can do with adjacent angles is we can actually add them together. So we can use something that's referred to as angle addition. All right, and if angle addition is going on here, what we're saying there is if you take angle BAC added onto, and again, angle B to A to C. That's how we talk about angles. We use 3 letters for the most part. We'll get in times we can use 1. And we add on angle CAD, all right, there to there. You're going to result in this large angle, which would be angle BAD. Yes, in geometry, it's fun to spell out 3-letter words. You do have angle bad here, all right? So that is one that we want to watch for. Vertical angles, another good vocabulary word. Vertical angles are always across from each other. All right. The reason why they are important is because they always have equal measures. All right. So they do have equal measures. So for example here, angle A is the exact same as angle B. All right. Now I shouldn't say angle A here. It's angle FCD. This measurement of A degrees would be the same as this particular amount that we're looking at. The other thing that we're going to see as well is we have another set of vertical angles. Yeah, right there. That guy is the same as that particular angle that we've got going on right there. Again, they are vertical angles. They are across from each other, so they will have equal measures. Angles on a line, also known as supplementary angles. These are angles whose, can I say that? Whose? Who is? I don't know. Angles that, here we go. Let's change words here. Add up to 180 degrees. All right. They're going to form a line. All right. So 180 degrees. So if we take this A to B to C, and if we add them all up, we would get 180 degrees because angle BAE does form a straight line, known as a straight angle. So it forms 180 degrees, yada, yada, yada. Excuse me. Okay, so next thing here is we got angles on a point, and it's kind of the whole idea is that if we go all the way around the particular circle, they have to add up to 360 degrees. So it's all the way around, and the big thing about this is, again, they add, so A degrees plus B degrees plus C degrees here would result in 360 degrees. Again, add them all up there. Kind of like a circle. Get it? Yeah, there we go. Yeah, all right. And then the last one we're going to make use out of here is what we call complementary angles. And this is 2 angles, and again, I'm using an angle symbol. I apologize if I didn't say that before. That is our angle symbol. It's kind of like an L that's slanted a little bit. 2 angles that add up to 90 degrees. So supplementary, they add up to 180 degrees. Complementary angles that are going to add up to your 90 degrees. And if we go ahead and add the 65 and the 25, that does give us 90. So more importantly, we put up right angle symbol, all right, not just the curve. The curve is what we use for angles. See curve, see curve, see curved. That's just for angle amounts. The actual box there is that right angle symbol that we're looking at. So the focus here is your ability to end up writing out equations. That's one of the things we're going to be watching for. And again, if you go back to your title, angle problems and solving equations. What we do want to look for here is see if we can find our particular angles that we're looking for. All right, and more specifically here, the first one who's up is we are looking for vertical angles. All right. Now again, vertical angles. Those are angles that are across from each other. Remember, they do have equal measures. So if you scan through here, you can see that we do have vertical angles here and here. Now we do want to name them here. We're just going to say 53 degrees and 53 degrees. We need to name that particular angle. So if I name this angle, I'm going to say angle CAE. And again, we're going from to vertex out to the other part of the angle. So again, we are tracing the angle there. Angle CAE and angle, and then we got BED. So angle bed there. All right, those are our vertical angles. Adjacent angles, there are a lot of them that are here. Again, as long as they share a common ray, we're good. So I'm going to go right here at the beginning, and I'm going to look at angle AEC. All right, and if I say AEC, who's going to be adjacent to that? You could give me two of them. You could give me two. All right, one particular choice would be angle, I think you probably said this one, CEF. All right, those are adjacent. Notice that they share letter-wise there. They're sharing the letter C and E. That would be your common ray. Or, all right, you can see the other one here. Instead of we can go to the other side, you could actually say angle AEG. All right, that would also be adjacent with angle AEC, A to E to G, because again, they share a common ray, and look at that, AE is shared there and there as well. Now again, adjacent angles don't give us too much information. It's just more that, well, if they're right next to each other, we can use angle addition, add them up to get that one larger angle. Angles on a supplementary, so we need to find our line. I do see a line that's going right here, so I could say from this angle to this angle to this angle. I see a line that's right there, so I go from this angle to this angle to this angle. Either one there, all right, and we're not going to list them all out here. We just want to make sure that we're seeing the straight path of points. And then we're not going to list out angles at a point because, again, that would be adding all of them up to form your 360. Angles at a point, not as important regarding vocabulary-wise. Supplementary certainly is. All right, so let's not waste any more time. Let's get to the good stuff here. Remember, it's all about writing your equations out. The big thing here is that you're just not putting answers down because, again, we're splashing in the kiddie pool right now. We got to make sure that we can float with our water wings on.
Elementary, my dear Watson.
Well, some of you might think that. So the big thing here is we want to know what our relationship here is. So you're going to see me go vocabulary here as well. I'm actually going to use supplementary angles here, and I don't mind if we kind of abbreviate there. The big thing here is, do you see the straight path of points? So we know when we add up angle X with 132 degrees, our result should be 180 degrees. Now, again, I know some of you are like, well, can't I just stack off the side and subtract? No. Excuse me. We are working with our solving equation skills as well, so we do want to bring out the basics there. So when we do subtract, we do get 48 degrees. So I need to see the equation. All right, I need to see your solving equation skills, and then you can go ahead and then we can go ahead and solve for it. All right. But yeah, so let's see what the next page has in store for us. All right, so find the measure of angle BAC and angle DAE, write an equation first. Okay, so first of all, that little box symbol is what? Yeah, 90 degrees, so that is a 90 degree angle. And again, we should see the straight path of points, so we know all of this has to add up to 180. So 3x plus 90 plus 2x has to result in 180 degrees. And again, we want to see your solving equation skills, so combine your like terms. 3x plus 2x is... yeah, it's 5x. Now we're going to undo any addition or subtraction. So we're going to subtract the 90 from both sides, which leaves us with 5x equals 90. And then we're going to divide both sides by 5. And 90 divided by 5 results in 16. Now we got to be careful here because we did solve. We got x equals 16. Yay! But no. Remember, the question was find the measure of angle BAC. So angle BAC, all right, B to A to C is 3x. So if we do 16 times 3, so it's actually 48 degrees. And then they want angle DAE, D to A to E, and that's a 2x. So that would be a 16 times a 2. So that would be 32 degrees. So there's our two official answers. You will see that a lot. So you do have to worry about what you're solving for, and then go ahead and plug that back in and make sure it all works out. What was the angle relationship I used here? Vocabulary wise, go on, say it. Yeah, supplementary angles. Bring it to that. Let's go to example number 2. We want to write an equation for the angle relationship for x and y, and then find those measures of those angles. So the big thing here is you got to go through vocabulary. And one thing I can look at there is I go, oh my goodness, look at this, straight path of point. I got a line here. It means it has to add up to 180. So that means 144 plus x has to result in 180. So that's my supplementary angles in action again. We're just going to solve the equation here. So x equals your 36 degrees. More importantly, how about letter y? And you might say, well, wait a second. I got a straight path of points here again. Can't I do the 36? I can, but oh my goodness, did you notice vertical angles? Do you see it? Do you see it? Do you see it? Yeah, so right away, y equals 144, done, show is over. All right, nothing more that goes along with that. Exercise 2 here, again, it's very puzzle-like when you think about these, and you have to realize what your options are. So the big options we've got running on right now are supplementary angles and then also your vertical angles. So we're going to try to use those guys to help ourselves out, and I'm looking to try to figure out where some of these pieces are. There's actually 2 different ways we can go about doing this. One particular way is sometimes you got to solve for another piece of the angle that they didn't even talk about. So, for example, I was like, wow, do I got vertical angles here with the 3x and the 85? Well, no, because see how that kind of bends there. But if this is 85 degrees, I can go ahead and solve for the other side over here, and this will actually give me 95 degrees. Now, why is that? Well, 85 plus, and I'll just call that y over there, has to equal, oh my goodness, how about 85 degrees plus y would have to result in 180, so that when I do subtract my 85 from both sides, I do get y equals 95 degrees. Now, why is that important? Because now I can go supplementary angles here and say, 95 plus 16 plus 3x, that's the result in 180. Now, again, this is very puzzle-like, where you might not see that at the beginning, but that's what we're going to go through of what can I use? Can I use vertical angles anywhere? Can I use my supplementary angles? It just takes getting time, getting used to the vocabulary. So if I do my 95 plus my 16, 1 carry the 1, 111 plus 3x equals 180. Subtract my 111. All right, and I'm going to get 3x equals, and I'm running out of space here, so I'm just going to slide it down a little bit. All right, 3x equals, all right, we get a 9 there. All right. And then we can divide both sides by 3. Sorry, I'm running out of space there. And you do get x equals 23. All right, so that definitely ends up working there. The other thing here is, oh wait, that's all they wanted. Oh, solve for x. Yeah, so I did that there. So that does work. So it's not 23 degrees, it's just 23. Here's the thing though, check this out. Again, different ways we can go about things. I do have vertical angles with this particular line, with this particular line. So 85, I'm going to do a separate problem here. 85 does equal 3x plus 16. If I subtract 16 from both sides and do my subtraction again, I get the exact same problem, and once again, I get 23 again. So multiple ways. This was actually a longer way of doing it over here. That got it done a lot faster. And that's what's going to happen sometimes. Sometimes you're just not going to find the short way. You're going to find the long way to get yourself through it. All right, so let's see here. The last page that we're looking at, the big thing here is we're going to use our idea of 360 degrees because, again, we are working all the way around. So you got your box there. Notice that it's a 90. All right, so if we go from here to here, it's a 90. From there to there, it's 135. From there to there, it is x. So if we add them all up, all right, and set it equal to 360. Now again, 360, I'm going all the way around to form the circle. Here's that making you dizzy? Is it? All right. So now we're going to combine some like terms. X plus, let's see, 90 plus 135, that's 225. Subtract your 225 from both sides. All right, and I am left with a 5 and a 3 and a 1 for 135 degrees. Just happening matched up to be the exact same. I don't have vertical angles here, so it's just kind of a coincidence that we did end up getting that. And let's look at the last one I've got here. All right. Again, it's comfort. That's why we want to kind of see a lot of them here. What we got. I don't have any straight line here to make 180 degrees. I don't have any vertical, but oh my goodness, we've gone all the way around. I'm going to use my 360 again. 103 plus 59 plus x plus 1 plus 167 has to equal 360. And I know what you're thinking. You're thinking, let's reach for the calculator. All right. But no. There's no need for that. Look at this. 59 and 1 is 60. 103 plus 167 is 270. All right. And then I got an x equals to 360. 60 and 270, yeah, 330 plus x equals 360, and then I can subtract it from both sides. So again, I know we're flying through the solving equations portions here, so definitely we want you to pause as we move forward with them. Again, it's just to kind of go through it. If you're comfortable with your solving equations, wonderful. If it's a little bit of a refresher here today and it took you a little longer to get through it, hey, that happens. But again, the goal here is to be able to write your equations out and then display that you can solve your equations. You got a nice little review that's down here, all right? And yeah, that's the start.
The first rule of Fight Club is you do not talk about Fight Club. The second rule of Fight Club is you do not talk about Fight Club.
It's okay to talk about math, though.